Good evening. You're welcome to our lectures for today. Today we'll take a look at chemistry. Chemistry. Today is what, 26th March 2024. So we are still on the topic kinetic theory of matter and gas laws. In our last lecture, we solved some questions on the gas law from Boyle's law to Charles' law, then pressure law. Then we solve questions on the general gas equation. So today we move to Dalton's law of partial pressure. Dalton's law of partial pressures. So Dalton's law of partial pressures, our reference book for today is New School Chemistry for Senior Secondary Schools by Oseyo Ababio, as edited, as revised by L.E.S. Apanisi and Herbert Igwe. 2016 edition. So most of the things we are going to discuss today will come from this textbook. And we also have our Prep 50 chemistry, UTME past questions. So let's go. So Dalton's law of partial pressures. Dalton's law of partial pressures states that if there is a mixture of gases, which do not react chemically together, if there is a mixture of gases which do not react chemically together, then the total pressure exerted by the mixture is the sum of the partial pressures of the individual gases that make up the mixture. You are lost. Okay. I say that Dalton's law of partial pressures states that if there is a mixture of gases which do not react chemically together, then the total pressure exerted by the mixture, is the sum of the partial pressures of the individual gases that make up the mixture. Are we together? Are you there? Partial pressures of the individual gases that make up the mixture. Now listen carefully, let me explain. Let's assume this is a container, right? A container that contains different gases, okay? A mixture of different gases. Are we together? A mixture of different gases. I use different shapes to represent different words, gases. Are we together? Each of them, or I can use A, B, C to represent each of the gases, okay? Any of them is okay. Each of them, remember that what is pressure? Pressure is nothing but what? The force of collision of this, each of the particles, okay? On the rod, the rod they are started here. Am I communicating? It constitutes their word, pressure, force per unit what? Area. Now, each of these gases have their own different pressures. Each one exerts different pressure. B exerts different pressure. When we use gas A, gas B, gas C, each of them exert their own what? Pressure. Different what? Pressure. Pressure A, pressure B, pressure C, pressure D. These pressures are known as the partial pressures. Are we together? Now, and the condition is that these gases are not reacting from some air. So that if we have oxygen and water, oxygen and the hydrogen, they react and form water now. No, there should be no chemical reaction between the gases. They are just a mixture. They just form a mixture. You know what a mixture is now? You just form a mixture in this container. Now, each of these pressure, each of these gases exert its own what? Pressure. Now, the pressure of this mixture of exerted by the entire mixture is equal to the sum of the partial pressure of these individual gases. Is it clear? Is it clear? So in that case now, P total pressure is equal to what? PA, partial pressure of what? The first gas, PB, partial pressure of the second gas, plus PC, partial pressure of the third gas, plus the last gas, depending on the number of gases in the what? Mixture. That's what this law says. Remember that the gases, they don't react what? Chemically together. Okay? That's a very important what? Condition. So let's continue. Another point I want to make here, there are some situations where the gases, maybe any of the gases or the gases is collected over water. Am I communicating? Over water, not as dry gas. Am I communicating? Sometimes the gas may be collected over water. If you go to preparation of some of these gases, you understand what I mean by collecting over what? Water. Non-metals and their properties now. If you go to properties of what? Maybe preparation of what? CO2, preparation of most of these gases, some are collected over what? Water. Am I communicating? Now, if the gas is collected over water, there is likelihood that you can put it down if you wish to. If a gas or the gas is collected over water, there is likelihood that it is saturated with what? Water vapor. Okay? If the gas is collected over water, there is likelihood that it is what? Saturated with what? Water vapor. So in that situation, the total pressure will give you the pressure of the gas itself plus the plus what? Pressure of what? Water what? Vapor. Okay? When it's collected over gas, don't worry, by the time we start solving questions, you see some question like that. Sorry, you just say over gas, collected over water. You see something, it can be confusing. In fact, this is what some students run away from questions from that partial pressure because of this issue of collecting over water. In that case now, PT is where the pressure of the gas plus pressure of what? Water what? Vapor. Or vapor pressure, anyone. That is total gas pressure. Total gas pressure. Maybe if a gas is collected over water, you see that the total pressure is what? The pressure of the gas, that is the dry gas, plus what? Pressure of the what? Water what? Vapor or vapor pressure, anyone. Are we together? Or you call it saturated vapor pressure. Anyone is okay. Okay. Is it clear? So with this, let's look for questions under this. We'll look at one question from this Dalton's law of partial pressure. Then we'll see how we'll take it up from there. All right, come and put down this question. That's the example from this textbook, example on number page 86. This example. Fast. This one. This one, yes. You can clean the board. Clean that side so that it will be clear. If the marker is not that clear, you can pick another marker. Sharon Pink, you're welcome. Fola Kemi, you're welcome. Thank you for following up. Sharon Pink, thank you for following. Young Billionaire, welcome. Okay, next question. The question says, a certain mass of hydrogen, a certain mass of hydrogen gas. Okay, you have to write down first. Yeah. Okay. Okay. Yeah, true. Okay. Okay, the question says, a certain mass of hydrogen gas collected over and 75 millimeter mercury pressure has a volume of 5 cm. Calculate the volume which is at the saturated vapor pressure of water at 6 degrees Celsius is what? 7 millimeter mercury. Now, if you watch, this hydrogen gas was collected solution. The hydrogen gas collected in water at 6 degrees Celsius. Water pressure will give us 65 millimeter mercury. How to do that? Total pressure 765 millimeter mercury because it was collected over what? Water. So remember that the total pressure is equal to pressure of what? Gas plus what? Saturated what? Vapor pressure. Water. So the The pressure of light gas is what I think for now. First of all, before you can do this calculation, you must calculate the pressure. Can you see the board? Come here. Yes, right? Before we can do anything in this nation, we must determine the pressure of the dry gas. If we determine it, we can now do the calculation. Is it clear? Good. So from this relationship now, pressure of the dry gas 7 watts, 65 millimeter minus what? Good. 7 millimeter mercury. 7 watts, millimeter mercury. What's the answer? 758 millimeter mercury. This is the pressure of the what? The dry gas. At, remember, the temperature is what? 6 degrees what? Celsius. Remember. Now, the question now is that we should calculate the calculate the volume of the gas at STP. At this 6 degrees Celsius what? So I follow you. 1 watts 5 cm cube. Let's calculate the volume when it's at in the case now, this crystals pressure and volume. That's equation. Two of us, but pressure, temperature is using general gas. P1 is P2V2 over what? From what we for what we say so far, let's the parameters. P1 is what? 7 watts. If you want the first set STP, no problem. P2 can be so, but it becomes an issue if you interchange them. That's one of the issues. Okay, so if you want the first of the word STP, so that P is what? STP. I don't understand by what you mean. I want the first state now. So there are first of pressure, temperature. This second set of what? Pressure. This is the initial volume, pressure, and temperature. Before you change to this, that's what I mean by first set. Out together. So if you want the first set to be the STP, no, if you want the first set to be STP, no problem. If you want, so if you want to set to be, one is what? I don't want to be P1 becomes this 7558 now. Why P1 is start 5 cm cube? P1 is what? Degree Celsius. Move it to what? Kelvin. Then P2 will now become an STP. P2 is what? 7 cm. Standard temperature is what? 273 Kelvin. So we are going to find the volume STP. Is it clear? If I use this if you use yes, that is where you use second set. Understand that way, so you don't make mistake. You want everything on the second set to be what? STP. That is the volume you are looking for. But if you move the first set, if you move STP the first set, you want to know what you are looking for. Huh? Okay. inside pressure, we have already tested the pressure of the oil gas. It should be 758. Is that what you mean? You meant plus what? 7 what? Millimeter mercury. Then one becomes what? 5 CMU. T1 is what? T1 is what? 6 plus what? 273 Kelvin, which is what? 279 watts. Okay. Then is what? Standard pressure is what? 760 watts liter mercury. Then T2 is what? Standard pressure is what? 273 Kelvin. Then V2 is what? Right? So we make it to the subject, the formula here. V2 becomes what? P1 V1 T2 over P2 T1. So this in Ghana P2 is not the first pressure was 7 mercury times V1 is what? 2 look at T2. P2 760 millimeter mercury times limited mercury will do what? Cancel limited mercury. We are left with what? CM cube. Let's get the answer. So don't waste time. Punch it fast and tell me the answer. What's the answer? Make it to one small place because that 2 CM is the answer. 34 point what? 2 Okay. I want us to look at another dimension of this law, of this law of partial pressure. Okay. When we are done, I want us to look at another dimension of this Dalton's law of pressure. We bring in more fraction into it. So, question and I'll ask you questions with respect to mole fraction, so you don't get confused what they mean by mole fraction. Okay? And let me know. fast. Iheramsi, welcome. Oluwatomi, welcome. Hello, welcome. Welcome. Solving questions. You're free to solve and drop your answer in the comments. Please follow up. Like the live and share. We are live here 3 p.m. to 6 p.m. Normal circumstance. We are here. Let's look at, I told that we will look at another dimension of the law of partial pressure. About the total pressure exerted. What we said about the total pressure exerted. And we know that if we experience using pressure of the gas itself, we say that the total pressure is equal to sum of the partial pressure of each of the gases in the this towards me and depending. To n, okay, means to the nth what? To the nth what? Gas. Now, remember, let's assume this is the container that contains the gases, right? We have gas A, gas B, gas C, gas A, whatever. Well, let's just stop at gas A, B, C, as the case may be. Together, each of the gases has its own pressure it exerts in this container, right? Now, the total pressure, provided that they don't chemically react, the total pressure is the sum of the partial pressure of these gases, these gases. But what we using what you call mole. You don't get confused. Now, you can mole ratio of the gases here. Inside ABC, okay. The total, the number of moles, the total moles here now is just the total, the number of moles of gas A plus what? Number of gas what? Okay, and what total mole of gas A, number of moles of gas B, and number of moles of gas what? C. Now, the more share of each of them now of the number of moles of gas A of what? N what? Total. Simple. Okay. Or you say is equal to N what? N A plus what? N plus what? N. That's meaning. Of what? Plus N plus C. Number of moles and see that's what we mean by mole ratio. So let's plug the whole method to give us. Let's plug the whole mole ratios, okay? The whole mole ratios, let's add them up. We have over what? plus C. MB what? M plus L. A plus what? I want to add what is the what? Equals M what? M plus what? C plus L is 1 times this is give us what? Plus 1 times this is what? Plus this line what? C. Which is what? M M what? C over what? M plus what? MC. The answer is what? 1. So if you want to like you add the entire ratios, it gives you what? 1. You this entire no ratio. You added all in this shop. For the entire shop, all the those acres in this shop of is all together. Easy with the individual gases. So individual gases is 1. So with the problem to points. Please welcome. As you are welcome. You are welcome. That I remember about things of fashion. So we talked about the turn of most is ABC. The turn of most is ABC. The turn of most is okay. Let me be clearing the side at you. What is that? In one is you're welcome. First way, you change from page 18 under law of for example. This is not right. Good. before we go into this question, there's something I want to point out. Well, I bring it to the partial pressure. Okay, please. That's here. I just prove this thing. Please, I want the relation for the law. Okay. So you can use the partial pressure move of a particular gas to set up with respect to what the partial pressure, the total pressure. Okay, you can use the mole fraction of a gas pressure and total pressure exerted. Okay, see what I mean? But if you have pressure, if you have pressure, the gas A, right? What gas A? Remember that pressure A is what? With the gas in of gas A, it is total A is one of gas A. N2 of the ratio, this number is up a proportion. What? Out to terminate your continue. So let's see what it will give you. Such script. Okay. Something come under here. Maybe theory ratio of over this equal to this over this. I like what you did though. I want you to bring under here. Bring this. It's okay. It's okay. You are already doing it here. Okay. So it's partial pressure of what? Times what? Moles. Total number of moles. Total number of moles thing is in order. You got it correct. Is to this. You cannot say you cannot say this over. Because you can also say the pressure total pressure is equal to what? Number of mode of total mode. Mode factor. Therefore, partial pressure is simply what? Total pressure times mole what? Fraction of what? A. Together. Equal to what? It's total. Fraction of what? Partial pressure. And things have gone out of the frame. Do you put this side down? I've got, sorry about this. Let's I can't bring that place have gone out of frame. So I started by saying that is in order. But sorry, you can look for it as out. Overall, PT is not to overall. PA equal to what? Times what? N over what? NT. A is what? A. The after pressure of A is equal to what? Total pressure of what? A. You can also extend gas B and C. Therefore, partial pressure of gas B is equal to what? Total pressure times mole of what? B. White pressure of C is total pressure I times fraction of what? C. So, power pressure, do not put it down. I did not complete it. So, if I think at this point we have completed everything, on this what? No, that is law of partial pressure. So, when you go to that question again, I'll write, please, you write that question again, solve it. Okay? All right, fast. So, Jerry, you're welcome. Liking the life. And Steph, you're welcome. Brother the mother, you're welcome. Fast, so you can solve questions. Tony, you're welcome. Rosen, like, share, invite others to join. We are here live 3 to 6 p.m. True. Okay, so let's look at that question. Please come and come around the question. You can now solve the question. I don't know if you are solving the question. I will explain to know. That's a question. Yeah, you know I claimed it. That should be this example one. Fast, fast, fast. C marker. Pretty white 333. You're welcome. Like, share, invite your friends, your colleagues to join us. We want to solve example number one. So we have, if you're able to solve it, you can solve and post in the comment section. Saturdays we'll start our mathematics competition. Sorry, our not just mathematics, other subjects. It tagged academic battle with from attending the school board here on TikTok. So if you are interested, please chat me up on WhatsApp for registration. It's just a token, and there are prizes to be won. So the free, if you are interested. Let's look at this question. The question is a gaseous mixture of 1.20 gram of hydrogen. Mixture of 1.20 gram of hydrogen and 6.40 gram of what? Oxygen. Total pressure of 997 molar mass of a substance means mass 1 mole of what? That substance. So since we now know this relationship, the number is equal to what? Reacting mass. Now let's find the number of moles of each of these gases, oxygen and what? Hydrogen. Are you following? So the number of moles, number of hydrogen is this. Reacting mass in this equation, what is the mass of hydrogen? In this question, what is the reacting mass of hydrogen? So here is 1.20 gram. Molar mass of hydrogen is what? Molar mass of hydrogen is what? 1. Is it 1? Mass of 1 mole of hydrogen is what? You consider the atomicity. 1 mole of hydrogen is what? See it by H2. Hydrogen exists as this now. 1 mole of it is, if you have hydrogen atom, that's why you get 1. But when you take hydrogen molecule, 1 mole of it is what? this is what this is the one here, right? So what of hiding by 2? Simple. Is what? The accommodation is what? It's not one will be using in your chemical one. So 1 is 2 is what? So that's mass of 1 molar mass of hydrogen. Molar mass of hydrogen is simply what? 2 times what? 1, which is what? 2 gram. The unit of molar mass, gram per what? Mole. Remember, so molar mass of hydrogen gas is what? Per what? Per mole. So if you divide this, what is that? Please, all please. You need to say gram, we can say gram. Mole, come. Yeah. The unit of the fire answer is you are saying to know. No. For this thing, for this thing. Hey. Continue for this is no. So this is because ground will do what? Cancel ground 0.6 mole. Are we together? Good. I add to this side because this side of frame. Please, I said must one gas is 2 times 1. Every should be what? Gram per watt, which is what? 2 gram per watt. No, that's what this. I think I remember this. Where? Here. Power the moves. So now that's to go because so 0 point. So molar the of moles of hydrogen is what? Now of moles of oxygen. M is this what? From the question, what is the from the question is What is the actual mass of oxygen here? For the question, 6.40 grams. Oh, the molar mass of hydrogen is oxygen is what? Oxygen is also diatomic now, which is what? 0.2, right? So this is it's 1 mole. It's not is visible. So the same multiplied with the which is oxygen is what? 16 times what? 32. This is not a number of oxygen is what? Is what? As well, you is changed. That's why I will ask you. Good. So what's the atomic mass of oxygen? 16. So this is what? But, I mean, what do you mean that the mass of water times what? 16, everything in gram per watt, which is what? 30 gram per watt. So we get here 32 gram no, green watt. That's what? That is. I thought you have a little bit here. You have found to this thing. 6.4 divided by there is no there is still this that should be by the side. Okay, now you get it by what? It's not true. 6 is what? 6 point what? 6.4. So you keep them aside. It's 4 by 2 is what? 2. The one by that thing. It give you what? 0 point. You need to get a calculator here. So 2. One question. I keep saying this number. You don't need a calculator jam question. Please. Because if that disappoints, sorry is your name. Predict. You see yourself, whether they will allow you to use it. 0.2 watts. N number mole of oxygen is what? All together. One interested in copying. No, I am. Are you sure? Are you sure? Alright. 0.2. We have succeeded number of moles of oxygen, number of moles of hydrogen, and number of moles of what? Of hydrogen. The total number of moles is now what? Empty is what? Empty is what? Which is what? What? 0.2 mole, which is what? 0.8 what? Moles. Confirm. Good. Look at this idea. And this we have them to us. The pressure of oxygen is what we were asked, right? We will not ask the partial pressure of what? Of what? Hydrogen. So let us not bother ourselves with that. But pressure. Can you stop my writing? We are giving pressure. Good. So if we are doing the total pressure, we can find the partial pressure of oxygen. So that total pressure of total numbers oxygen about total of us. Of oxygen, let's go straight to the point. No fraction of oxygen is what? Is what? Pressure. From this thing now, from what we have done, so what how at this point now, calculate the total the oxygen from here. What the formula is going to
to be pressure of number of pressure of equals to total pressure times mole fraction.
good. So what is that mole fraction?
Fraction is mole fraction. Mole fraction is
The mole fraction.
the mole fraction is NO.
It seems you are still having issues with this mole fraction.
N over NT.
Stop telling me. Entertain what it means.
Of mole over total mole, total number of.
Good. So that's what we used to find this thing now. Is that clear? So simply, we can allow you put this in down so we can clean the board. Then we conclude fast. Fast. Welcome. Welcome. Tobiloba Ogunmeyi, welcome. Tobiloba Ogunmeyi, welcome. Share. Invite your friends to join. You and General, welcome. Das of Gemini and Scorpio, welcome. Lovett SB, welcome. We are done. All right, so let's take in the continue from where we start. So having of oxygen, number of moles of hydrogen, and also the total moles. Let us now look at what? The partial pressure of what? Oxides. So more of what? Number of moles of water what? Number of oxygen. Moles over what? 0.8 moles. Okay? Everything is what? 0.2 mole divided by 0.8 is what? The same no term. Just clear everything. If you move this out now, here we can move this out. Comes a that 2 term. 2 without 2 what? 1 over 4. 0.25. Okay, leave that 1 over 4. I said. The 1 over 8 is what? 1 goes there. 1 to go there for 1 over. This one is 0.25. Can figure out now. Now, I did this for in case what you need to be okay. Let's leave it at 1 over 4. Now, this action. Now, remember that formula we did for is that total pressure of 40 here will now become what? Total right times what? No fraction of what? Oxygen. Simple. So total pressure is what? From 9 what? Now, yeah. Leave it like that. Both seconds for don't punch all the time. Don't answer. Don't divide it by yourself. Fast. I give you 20. I give you 10 seconds. You did next to in the article. Fast. Precious. Ajike, Swema Juicy, you're welcome. Free. What's the answer? Nobody is on today. What's the answer? 84. is, let's start from here. Why 9 is number 1, right? Remember, this is in base 10, right? You must render what? 1, right? You multiply 1 by the base, 1 times this what? Add it to this one, it becomes what? 19. 19 divided by 4 is what? 4 minus 3. You multiply by the base you're working on. 3 times 10 is what? 30. 7 becomes 37. 37 divided by 4 is what? 36 is what? It's not 9. 4 times 9 is what? 4 times 9 is what? What if you see? 36 now. So we have 9 remainder what? 9 what? 1. Good. You multiply by the base you are working on, right? 1 times what? 10. Because nothing here again to add it to. 0, you are adding it to now. Put this point here. Am I communicating? So you are there by 4. Put this be what?
2.
You put 2, right? That's the limit. By the 2 times 10 is what? There are not to add it, right? 4 is what? 4, 5. We have 249.25 point check check whether you send. Please learn how to do this thing. It will help you. Two five, right? So this is a what? A partial. You can, okay. But if you do you for the one you do for. If there's no option like that, you just less like this, okay? 249 point what? 25 is it clear? This is a partial oxygen. Any question ask. Any question ask. Adenike, you are welcome. Oyeto, you are welcome. Socks, you are welcome. You are welcome. Any question? We have roughly understood. We have only 15 minutes. So let's send one question, okay? In the next class, the next law. I think we have done justice this law. Study more on these gas laws. Any question here? Any confusion? Are you sure? Okay. No question.
pH is what?
pH. What's that pressure of hydrogen?
The number of moles of water.
Which one? Olivia Mia, welcome. Official Pedisoft, you're welcome. Christian Perry, you're welcome. Like, share, follow us. Cassie K, you're welcome. Prince K, Jamaica, you're welcome. Subscribe to our YouTube channel from a country. Simon, you're welcome. John Elijah, you're welcome. Soft Skyber, you're welcome. Christian Perry, thank you for him. Nifi, you're welcome. Follow us and subscribe to our YouTube channel. Thanks. Like Bridget Williams, you're welcome. You're welcome. You're welcome. Chase, you're welcome. The question say a mixture of this question from JAM question 1997 question it says a mixture of 0.20 mole of argon, okay, 0.20 mole of nitrogen and 0.30 mole of helium exerts a total pressure of 0.1 atmosphere, comma, the partial pressure of helium in mixture is A, 0.90 atmosphere, B, 0.80 atmosphere, C, atmosphere, D, 0.60 atmosphere. Okay, let's solve this question. Solution. Therefore, is direct. Or the previous question where the amount was given gram, where you start converting from gram to mole using what? The reactive mass, using the relationship between the reactive mass, molar mass, and what? Number of mole. But the belief is to use straight in mole, so you don't need to do any conversion again. Just quote the formula and solve whatever you want to solve, right? Now, for the formula you're given now, we are looking at the partial pressure of what? Helium. So, partial pressure of helium is simply what? Total what? Pressure times what? Times what? Mole fraction of what? Helium. Simple. So let's look at what the total pressure. From the question, three gases is from helium and what? Nitrogen. So total pressure is simply what? Partial pressure of what? Helium, right? Plus partial pressure of what? Nitrogen. I feel good. This is simply what? What is partial pressure of? What's the partial pressure of helium? We don't know, right? We don't know, right? Good. What is partial pressure of argon? We don't know, right? What is partial pressure of nitrogen? We don't know. Partial pressure. So this is simply what? How many atmosphere? 2.1 what? Atmosphere. Look at it. Total pressure is what? 0.1 what? Atmosphere. What's that? I don't like that same position. You look lost from your facial expression. Okay, sure. So, I intend these things first. Okay? Can you state it? The question, they didn't use any of that. Anything still to put atmosphere. So, we know now, let's go to mole fraction. Fraction of helium is simply what? The number of mole of what? Helium over what? Total number of moles. So let's look at the total mole of what it is in the mix. Total of moles is equal to what? Number of mole of helium, right? Plus number of mole of what? Argon, right? So the number of mole of what? Nitrogen, which is what? of mole of helium is what? From the question is what? Number of mole of helium from the question is what? Good. 0.3 mole plus number of argon is what? 0.2 mole plus is what? 2. So it's 9 what? 0. Mole. So now we have gotten our what? Mole ratio. So let's ask a question. Total pressure of helium what? Total pressure which is what? 2.1 iPhone 2.1 what? Atmosphere times what? 0.7. Something is lacking. Tell me what is lacking from here. Mole fraction. Good. You only calculate the total number of moles. So mole fraction of helium is what? Number of mole of helium which is what? 0.3 moles over what? 7 moles. What will be what? Times 2 moles. What should it be? Leave it in fraction so that we can substitute and get our answer. Just fraction. Please tell me. Don't keep quiet. I explain this to you. Something. Tell me.
1 over.
But sum up. So that's the answer to bring this in fast. Move it ahead. The answer straight. Hey, wow. So now let's go here. I want to leave it as a fraction. What are you counting again? Leave it as what? Fraction. Simple. That's what I said. If you watch now, mole ratio has been it, right? Good. Now, leave it at 3%. This will help you in calculation. So you don't need to go and start carrying what? Calculator. Now, this is the what? The mole fraction. Now, let's go back to the formula. The partial pressure of helium is now what? Total pressure is what? You are tired, right?
And 2.1.
You are losing focus.
2.1 atmosphere.
Right?
I'm not tired.
So then why are you sounding like this?
Because I'm not eating.
Why haven't you eaten? You're coming to class, you not eat. So here is
2.1 atmosphere.
2.1 atmosphere times what? 3 over what? So confirm. So what is the answer? What is the answer? What's the answer? See, why are you keep that thing. This is why people jam. They will go confused. Why are you creating bogus number for yourself? Why are you multiplying bogus number for yourself? It doesn't make sense. Stop creating bogus number for yourself. Can you sit well? Uh-huh. So, here. Alright, so let's conclude. So you don't need to just number. This is just 2.1. You can move that 10. Keep that side. 2 is what? 3. 3 times 3 is what? 9. Bring back the 10. Divide by 10 is what? 0.1. 9 atmosphere. Which one is the answer here? A is the answer. Okay? Is it clear? Yeah. Okay. So we end class. On a Z, welcome. Okay, so thank you so much for your attention. And see, meet us tomorrow here, same 3 p.m. 3 p.m. we are here. Bless you, join us. Please, for lectures, please subscribe to our YouTube channel. The name is the school from eternity. The school board. Go to our YouTube channel. Subscribe. Just the bell do upload first people to their life. Please comment, share, invite your friends, and God will as you do so. If you find these lectures interesting, please appreciate by inviting us. We are here to help in our own way. God bless you as you do so. See you tomorrow.